Next, we have velocity. Velocity describes how fast an object's position is changing. Specifically, average velocity is the displacement divided by the time interval over which the displacement occurred. It's a vector, just like displacement. Its sign tells you the direction of motion. A positive velocity means moving in the positive direction. A negative velocity means moving in the negative direction. Let's look at an example. The straight line distance from Atlanta, Georgia to St. Petersburg, Florida is about 500 miles. If someone drives the car the distance in 10 hours, the car's average speed is 500 miles divided by 10 hours or 50 miles per hour. It doesn't matter if the driver's speed changes during the trip. The driver could run into traffic and have to slow down or stop along the way, or drive faster for part of the trip. The average speed is still the same. But let's say the driver makes a side trip to Jacksonville, Florida, which might add 100 miles to the path length. So now the car average speed is 60 miles per hour. Distance is the length of straight line joining 2 points, and the path length is the length of the actual path traveled between 2 points. Using our previous example, the average velocity between point A and B is the displacement, 22 meters. If it takes 10 seconds, then divide by 10 seconds, which gives us 2.2 meters per second. The average velocity between C and F is the displacement, which is minus 91 meters divided by the time it takes, let's say 30 seconds. Then the average velocity is going to be about negative 3 meters per second. Now keep in mind this is average velocity this time. To get the data in the table giving us the position of the car at different times, let's find the average velocity in the time interval from point A and B. Imagine we are watching a drag race from a stationary. The paths of a car are depicted in the figure. In one run, we see the car follows straight line path, showing in orange, from P to Q during the time interval delta t, and in a second run, the car follows the curved path, shown in blue during the same interval. The two cars had the same average velocity because they had the same displacement during the same time interval. The car takes the curved route traveling a greater path length had the higher average speed. So this is the distinction between average speed and average velocity. Average velocity really only cares about your starting point and your end point. But average speed depends on how you drive, the path you took. We can also visualize velocity on a positive position versus time graph. The average velocity between any 2 points is simply the slope of the straight line joining those 2 points on the graph. A steep slope means a high velocity. A flat slope means a low velocity. A positive slope means positive velocity, and a negative slope means negative velocity. Now, average velocity is useful, but what if we want to know how fast something is moving at a single moment in time? For that, we need instantaneous velocity. This is what your car speedometer shows you. Your velocity at that exact instance. Mathematically, we find the instantaneous velocity by calculating the average velocity over a very, very short time interval. As the time interval approaching zero, the average velocity approaching the instantaneous velocity. Graphically, the instantaneous velocity at a specific time is the slope of the tangent line to the position versus time curve at the exact point in time. It tells us how fast the object is moving and in what direction at the moment. This is a few questions I ask you to think about. We take a trip from Jacksonville to Orlando. Now, what shows on the Google map, 143 miles, is this displacement, the magnitude of a displacement, or is this distance? What's the average velocity of this trip? What's the distance of this trip? What's the displacement of the trip? Yeah, think about this. Another question I want you to think about. Which figure in this velocity versus time graph of a microscope whose speed is increasing? Now, this one is also could be also a little bit confusing. Okay, I want you to think about it, and maybe you can write an email to me to tell me which one you think is the correct answer.